Forged, how steel is made. It is the most produced metal on Earth, 1.9 billion tons every year. It is in your car, your refrigerator, your building's frame, the bridge you drove over this morning, the surgical tools that saved someone's life last week, and almost nobody knows how it goes from a hole in the ground to all of that. This is how. Steel starts as iron ore, a reddish, rust-colored rock found in massive deposits in Brazil, Australia, India, and China. The ore contains iron bonded with oxygen and a range of other impurities, silicon, phosphorus, sulfur, and manganese. None of those belong in steel. The entire steelmaking process is essentially a very sophisticated, very hot method of getting rid of everything that is not iron, and then adding back a precisely controlled amount of carbon. The ore goes into a blast furnace, a tower that can stand 60 meters tall, lined with heat-resistant brick, running continuously at temperatures around 1500 to 1600 degrees Celsius. Three things go in: the iron ore, coke, which is coal that has been heated to remove impurities and becomes almost pure carbon, and limestone, which acts as a flux to pull the silica and other impurities out of the iron and float them to the surface as slag. The coke burns and generates the heat. The limestone captures the garbage. The iron melts and sinks to the bottom. What comes out of the bottom of the blast furnace is called pig iron. It contains about 4% carbon, far too much for most uses. High carbon iron is brittle. It shatters rather than bends. To make steel, you need to bring the carbon content down to somewhere between 0.1 and 2%, depending on what the steel is going to be used for. The process of doing that is called steelmaking, and it went through a revolution in the 1850s that changed the world. In 1856, an English engineer named Henry Bessemer discovered something extraordinary. If you blow air through molten pig iron, the oxygen in the air burns off the excess carbon almost instantly. The carbon combusts. The temperature actually rises during the process. The burning carbon adds heat. What had previously taken days in a forge could now be done in 20 minutes in a Bessemer converter. Steel went from being an expensive specialty material to something that could be produced cheaply at scale. The railroads, the skyscrapers, the bridges of the Industrial Revolution, all of that became possible because of that discovery. Modern steelmaking uses a refined version of the same principle called the basic oxygen furnace. Instead of blowing air through the molten iron, a lance is lowered into the furnace and pure oxygen is blasted in its supersonic speed. The oxygen reacts with the carbon and burns it off in a spectacular display of flame and sparks. The entire heat, the industry term for a batch of steel, takes 20 to 40 minutes to complete, from liquid pig iron to liquid steel, in less time than it takes to watch a movie. The other main method is the electric arc furnace. Instead of starting with pig iron from ore, the 8IF starts with scrap steel, old cars, demolished buildings, discarded appliances. Enormous electrodes create an electric arc that reaches temperatures of 3000 degrees, melting the scrap entirely. The AAF is how most recycled steel is made, and steel is the most recycled material on Earth. Over 80% of steel ever made has been recycled at least once. The can you recycled last week may become a car door or a structural beam. Once the liquid steel reaches the right carbon content, it is tapped from the furnace and goes through secondary metallurgy, a refining stage where precise alloy additions are made. Chromium for stainless steel, manganese for high-strength steel, nickel, molybdenum, vanadium. Each addition changes the final properties of the steel in specific ways. The steel for a surgical scalpel has a completely different chemical composition than the steel for a ship hull or a car body panel or a railway track. They are all steel, they are all different. The liquid steel then goes to continuous casting. It is poured into water-cooled molds that shape it into slabs, billets, or blooms as it solidifies. Long rectangular sections that emerge from the caster still red-hot and get cut to length. These go directly into rolling mills, where they pass through sets of powered rollers that squeeze and elongate the steel into its final shape: flat sheets, I-beams, wire rod, rebar, pipe, rail. The rolling process also improves the steel's grain structure and mechanical properties. The steel in your car door started as iron ore in a mine. It was charged into a blast furnace with coke and limestone, refined in a basic oxygen furnace, alloyed to specification, continuously cast into a slab, hot roll, cold roll to precise thickness, coated to resist corrosion, stamped into shape, and welded into position, all before it got painted. Over 100 separate steps between rock in the ground and door panel on your car. Follow Forged, how the things you love are actually made. Link in bio.